Hello ladies and gentlemen, my name is Joel and along with my group members Caris and Rohan, we will be presenting to you on our biostatistics PBL. Our topic of choice for this PBL is, do obese males have a higher mean level of cholesterol as compared to underweight males? So why exactly did our group choose to go into this topic? Well, according to a study by the United States Department of Health, excessive cholesterol in the blood can cause hardening and result in
leading to heart disease. As a result, our group decided to choose this topic to investigate if weight is related to cholesterol levels.
Okay, well, I'm back now, but just for a short while because right now, Caris will be presenting to you on the descriptive statistics part of the PBL.
Hi, I'm Caris, and now I'll be presenting to you the descriptive statistics for this PBL. This table shows the descriptive stats of the results that we tabulated from Minitab. From this table, you can see that the first column represents the total cholesterol for obese male, and the second column represents the total cholesterol for underweight male. As you can see, the range that is highlighted in yellow represents the range of the data for each category. The median, mean and mode, which is highlighted in green, represents what we're going to use to calculate central tendency. The median represents the middle value for each data set. The mean represents the average value for each data set, and the mode represents the highest frequency from each data set. The variance and standard deviation, both highlighted in pink, are used to conduct the hypothesis test. From the results, we constructed a histogram. This histogram shows the frequency of total cholesterol level for obese males. And from the histogram, we can conclude the skewness and the kurtosis of this data set. The skewness of this histogram is 0.57. As the value is between -2 and 2, it shows that the graph is approximately symmetrical about the middle line. The kurtosis of this histogram is 0.16. As the value is between -2 and 2, it shows that the graph is bell-shaped, indicating a normal distribution. This histogram shows the frequency of total cholesterol for underweight males. From this histogram, we can also determine the skewness and kurtosis. The skewness of this histogram is 0.83. As the value is between -2 and 2, it shows that the graph is approximately symmetrical about the middle line. The kurtosis of this graph is 2.31. As the value is above 2, it shows that the graph is sharply peaked, indicating a triangular distribution. We constructed a box plot, and from this, we compared the upper quartile and lower quartile along with the mean, median, and mode. And for all the values, the obese male group showed a larger value as compared to the underweight male group.
In the case of this project, the research question is, do obese males have a higher mean level of cholesterol as compared to underweight males? We will now conduct a hypothesis test to show if our theory is true. Mu1 is defined as the mean level of cholesterol in obese males, while mu2 is defined as the mean level of cholesterol in underweight males. First, we define H0 as mu1 minus mu2 equals to 0, while the alternative hypothesis is defined as mu1 minus mu2 is more than 0, where we expect cholesterol levels to be higher in overweight males than in underweight males. Now, because population standard deviation is unknown, we have to conduct a F-test to see if the variances are equal. In this F-test, the null hypothesis is as follows. H0 is sigma 1 square divided by sigma 2 square equals to 0, while the alternative hypothesis is sigma 1 square divided by sigma 2 square is not equals to 0. From Minitab, we have to perform the F-test at alpha equals to 0.05 with V1 equals to 49 and V2 also equals to 49. So the p-value from Minitab given is 0.969. Since 0.969 is more than 0.05, there is insufficient evidence to reject H0. The test concludes that variances are all equal. Since F-test concluded equal variances, we use two samples t-test. We will also need information from mini-tab done earlier of sample mean 1 equals to 236.22 and sample mean 2 208.68. With the information taken, assuming equal variances, the mini-tab output is given such that the test statistics is 3.59 while the p-value is 0.00. Since the p-value is 0, which is less than 0.01, H0 is rejected. The test is significant and there is sufficient evidence to show that the mean level of cholesterol is higher in obese males than in underweight males. The 99% lower bound confidence interval for this right-tailed test is calculated to be more than or equals to 9.40. With the lower bound confidence interval calculated, we can say that for every 100 tests conducted, 99 of these tests will fall in the range of more than or equals to 9.40.
As in all hypothesis tests, there are errors. In the case of our PBL, there's a type 1 error and a type 2 error. The type 1 error is that we reject H0 when it is true, and the type 2 error is that we do not reject H0 when it is false. What are the possible repercussions of a type 1 error? First of all, there may be wastage of resources such as time and money. In both stakeholders' perspectives, from the patient's perspectives, they may be wasting time because they are going for treatments or going for checkups to find out if their level of cholesterol is high or if it's above the threshold when it is in fact okay. By going by checkups, they may also waste their money paying for the healthcare services they do not need. And as for the healthcare specialists or researchers, from their point of view, they may be wasting time in trying to find a cure that is not needed, and funds may be also channeled wrongly or incorrectly. And there's also a false sense of panic as the obese males are afraid that they will get heart attacks when they are in fact in safe hands. Now on to the type 2 error. So what are the possible repercussions of a type 2 error? First, the obese males will live in a false sense of security as they may think that their cholesterol level is fine when it is in fact not. And as a result, there's no action taken to solve the problem by the people itself or by researchers, and nobody invests anything to develop a cure to lower cholesterol level, which may result in more number of people suffering from heart diseases. And with that, we have come to the conclusion from the PBL. On behalf of the group, I would like to thank everyone for giving us their time, and we wish you a Merry Christmas and Happy Holidays.